Assalamu alaikum wa rahmatullah. Solid modeling using Inventor. This is lecture number 7. This lecture talk about how to use Inventor to design a sheet metal. That means we will use Inventor in sheet metal working. As you see in that display, this is the Inventor. To open sheet metal file, modeling file or part file, go to new. At the beginning you have to select the units, English units or metric. Assume metric units. So as you see, we have standard part here and we have sheet metal part. The difference between the sheet metal part and standard part, first of all, they are both parts. So you can design a part using sheet metal or standard one. Anything can be done in sheet metal, can be done in standard or opposite. But sheet metal working difference, or it is different than the standard part, because the sheet metal, in sheet metal we have uniform thickness, while in the part doesn't matter what is the thickness, is it uniform or not. So you can design any 3D part, but in sheet metal the thickness of the sheet will be uniform. As example, for extrude, no need to indicate the height, because by default the height will be the thickness of the sheet. And second thing, in sheet metal working user interface, we have some useful tools to help us to design a sheet metal, not like the standard part. But again, I can do everything using the standard part, but it will be more difficult to me to design sheet metal in the standard part, but I can do it at the end. So I prefer or recommend the sheet metal millimeter. I'll see here we have the user interface. This is 2D sketch like the regular part. Here we have 3D model like the regular Inventor parts. To start sheet metal, say we have to start a sketch, select one of the work planes, say XY plane origin. As example, let me draw a rectangle. The center of the rectangle, center of the file. Surely we have to constrain the rectangle by writing some dimensions. Imagine that the length will be 100, zoom in, the height or the width should be 50, finish the sketch exactly like the part modeling. Once we finish the sketch, we can see the sheet metal 3D tools. As example, if you remember in Inventor part, if I want to extrude the rectangle to get a box, we can use extrude. Here a face, just a face, so face equivalent to extrude. By default the Inventor will select the sketch number 1, and as you see, there is no any way to enter the thickness here or the height of extrusion or height of the face, because it will take it from the default value. I will show you how to change the default value. Now you can change the direction of the face, then select OK, cancel. Now I'll see how much the thickness, I don't know. It's uniform thickness. Can we change it? Yes, we can go after the first step or any time or before. You can go to sheet metal defaults and then here remove this one and select the thickness you want. As example, say 5mm sheet metal thickness. Apply. Maybe 5 is too much. Say that 3. Apply. OK. Or make it 2mm better for our design. Apply. Cancel. Now say that I want to create a gap or a hole, rectangular hole inside the face. As the Inventor part, we have to draw a sketch on this face as example. Say that I want to create a rectangular gap, so I will draw a rectangle, center of the rectangle, center of the face. Surely I have to constrain by writing some dimensions. Say that it should be 50 by 25. Finish the sketch. Now I want to make a cut. Do you remember Inventor part? You have to select extrude, then cut. But here, just select this tool, cut directly. By default, the solid and the face selected by Inventor. You can indicate the thickness you want, distance you want. Is it to thickness or to write some distance or whatever. You have some options here. You can change the direction, but this is a cut, no need to change direction. Keep it as it is and then press OK. Then we created the cut. Imagine that I want to create a flange here. So I will go to flange, create a flange by adding sheet metal face and bend to an edge or edge loop on existing face. So I'll see now we can use this edge or this edge, it's up to you. Say that I want to use this edge. You have some options how you can select the height datum, the bend position. They say that I want to bend adjacent faces like this. How much the height of this bend, is it 25, is it 50 as example. Direction of the bend like this or like that, then select OK. I will create another flange to the right, so I will make rotation, then I will use flange. I will select this edge again, same settings, apply, cancel. I will get this shape as you see from the front view, I will see from the bottom view. Go back to home again. Now guys, say that I want to fold this flange from the middle, so I have to create a sketch on this face as example. You can create, say that at the middle, so I will select a line, draw a line from the middle point to the middle point, then finish your sketch. Now I have to go to, as example, fold and select the line, folding line. As you have some options here. This from the center or center line of the bend. You have some options here also. You can change the flip direction. Do you want it up or down, right or left? Say that keep it up to right. Apply, cancel. I want to make the same thing for the other side. I will go to this face again, create sketch, go to the face, maybe draw a line at the middle exactly. So I think this is, I don't know where is the middle point. Let me do it like this. I think this is the middle point. Let me remove this constraint or do it again. Draw a line from, yes, this is the middle point, center point or middle point. Now finish your sketch again. Say that we want to fold, select the tool. Same settings, apply, cancel, and we can check it from the this view. As you see, go back to the isometric or any 3D view. Now say that I want to fold all of the objects from the middle, or let me create a cut here. So I want to place a sketch here in this work plane. The sketch, say that it is a rectangle shape at the middle center or middle line. Now I will make a cut. By default everything okay, cut. I'll see. Now say that I want to fold the object using a line drawn here, so I will sketch on this work plane or this surface. I will draw a line, say that from this point to this point. Again, finish the sketch. You can now use the fold, select the line. We can select this line, maybe there is some constraints or something wrong. Let me do it again, remove this sketch, sketch on this work plane. Again, draw this line from here to here. This is the mistake. Let me delete the line again, draw the line from this point. Be sure that I selected the correct point. Okay, finish. Okay, now we have to go to fold, select the line. We can select the line. So let me delete the line again. I don't know what's wrong here. Maybe constraint, maybe something. So let me delete the sketch or edit the sketch again. And let me delete the old line and create a new line. So Now finish your sketch. Now we can go to fold. Select the line. You can select the direction and the angle. So let me make it 45 angle up. Very good. Now how we can fill the gap in between here? We can use the bend. Bend actually it creates feature that connect two disjointed planar faces. So I want to create or fill between this edge and this edge. You have some options here. You can select anyone you want. Just apply for me. It will be okay. Now say that I want to say that this edge or this edge, sharp edge, I want to bend it. So I will use him. I just see here, just select the edge, say that this edge. There are some parameters you have to enter as example. How much the gap here, this gap, how much this gap, is it half of the thickness? It's okay for me. How much the length of the him, is it 4 times the thickness? Maybe for me it's 2, it's okay according to the design. Apply here. You can go to the other edge like this, do it the same. Now guys, say that I want to unfold and bring it back to flat position. Say that we can go to select unfold as example. We need a stationary reference. Select this line as a stationary reference, and then we'll select the bend. Which bend we want to unfold? Say that this one. That's it. Then apply, cancel. As you see, it goes back to the original or flat shape. This is sheet metal working part 1. Say that we'll continue.